Hey everyone, welcome back. This is lesson 4-2, Multiplying Matrices. All right, the objectives for today, you're going to be able to understand the properties of matrices with respect to multiplication, and you're going to be able to multiply two matrices. The vocabulary for today is matrix product, square matrix, main diagonal, and the multiplicative identity matrix. In lesson 4.1, you multiplied matrices by a number called a scalar. You can also multiply matrices together. The product of two or more matrices is the matrix product. The following rules apply when multiplying matrices. Matrices A and B can be multiplied only if the number of columns in A equals the number of rows in B. And the product of M by N and an N by P matrix is an M by P matrix. Now that sounds really messy, but let's just look at what it really means. All right, let's look at these two examples. Looking at matrix A and B, if we multiplied those together, we have to find out first if the columns equals the row. So we're going to put A here. A has 2 rows by 3 columns, and B has 3 rows and 4 columns. So if we write them together like this, we see the two inside terms, 3 and 3, our columns equals our rows. So that's a check. So we can multiply these together. And when we do multiply them, the product matrix will be a 2 by 4. The dimensions of the product matrix will be 2 by 4. And that's these two outside numbers here, 2 and a 4. All right, let's check C and D. If we multiply C, first we look at that, and it has 3 rows and 2 columns. And then we look at matrix D, and it has 3 rows and 5 columns. Well, let's look and see if our columns equal our rows. No, it does not. 2 does not equal 3, so CD is not defined, and so because we can't have a 2 by 3, 2 doesn't equal 3, so this is not, we don't have to do anything on this particular matrix multiplication. All right, here's a helpful hint. If it's helpful to you, great. If it's not, oh well. So remember the car key. The columns of A as rows of B, or the matrix products AB, won't even start. So you have to have the columns of A equaling the row of B, or you can't even multiply. So just a little hint there. All right, so let's look at this example. We want to tell whether the product is defined, and if so, give its dimensions. So let's look at A. The dimensions of A are 3 by 4, and the dimensions of B are 4 by 2. And we can see that the columns equals the rows, and so that is true. So we can multiply, and the dimensions then of the product is going to be 3 by 2. So it's pretty simple. The inner dimensions are equal, so the matrix product is defined, and the dimensions of the product are the outer numbers 3 by 2. All right, let's try another one. Tell whether the product is defined. If so, give its dimensions. So let's see. C is, the dimensions are 1 by 4, 1 row, 4 columns, and D is 3 rows by 4 columns. So when we look at the rows and columns, they do not equal each other, so this is undefined, and we can't do any more multiplication. The inner dimensions are not equal, so the matrix product is not defined. Here's another one. Tell whether the product is defined. If so, give its dimensions. Okay, QP. So let's write our Q is 5 by 3, and our P is 2 by 5. So when we do that, we see that the 3 is not equal to 2, so our matrix cannot be defined or multiplied. The inner dimensions are not equal, so the matrix product is not defined. All right, try about SR. Again, S is 4 by 5. R is 4 by 3. 5 does not equal 4, so the matrix product is not defined. How about S and Q? S is 4 by 5. Q is 5 by 3. The inner products are equal to each other, so the matrix product is defined. If the matrix product is defined, the dimensions are going to be 4 by 3. 4 by 3. All right, so just as you look across columns of A and down the rows of B to see if a product A exists, you do the same to find the entries in a matrix product. All right, just to give you a brief overview of what we're going to do to be able to multiply matrices together, we're going to take the pieces of the row and multiply it by the pieces of the column, add each of those together to get our new product in our product matrices. So it looks kind of complicated here, so I want to show you another picture real quick. All right, so basically what we're going to do is we're going to take what's in A, 1, 1, and B, 1, 2. We're going to multiply those together, and then we're going to multiply these two together, add all of those up together, and that's going to go in the slot where the two intersect. And same with another one. We're going to do this for each different slot. I just had it so you could see a little bit better. So we're going to take what's in A, 3, 1, multiply it in B, 1, 3, and then we're going to take what's in A, 3, 2, multiply it in what's in B, 2, 3. We're going to add all those up together, and they're going to go in this slot where the two intersect with each other. All right, so that's kind of an overview of what it's going to look like. So let's do a sample one. So here is our problem. It says, what is the product? Find the product, if possible, of WX. So first thing we need to do is check our dimensions of WX. So I can see that WX is a 3 rows by 2 columns, and X is 2 rows by, let me move this over just a little bit, 2 rows by 3 columns. So we can see that our inner two terms are equal, so we will be able to multiply these, and our new matrix is going to be a 3 by 3. All right, I'm going to do this really slow for you. So let's take a look. All right, so what we're going to do is we're going to first write our two matrices. This is W and this is X, and we're going to start multiplying them together. So I like using a highlighter a little bit. So I'm going to take 3 times 4, and multiply them together, and that's 12, and negative 2 and 5, and multiply those together. That's negative 10. So 12 plus negative 10 is a positive 2, and that goes in this very first position. All right? Now, let's try the next one. We're going to take the same row, second column. So I'm going to say 3 times 7 plus negative 2 times 1. And so that's 21 plus a negative 2 is a positive 19, and that goes in our second spot. All right, let's move on. Same row, the third column now. So 3 times 2 is negative 6, and then negative 2 times negative 1 is positive 2. So negative 6 and a positive 2 gives us a negative 4. So there's how we get our next position. Now we're going to go to the second row. All right, second row, first column. We're going to do it over again. 1 times 4 plus 0 times 5. All right, and that's 4. Next, same row, second column. 1 times 7 plus 0 times 1. Add those together, we get 7. All right, same thing. Second row, third column now. 1 times negative 2 plus 0 times negative 1, and that goes in the next slot. All right, here we go again. Now we're into the third row. 2 times 4 plus negative 1 times 5. When we add that, we get a 3. All right, same thing. Third row, second column. 2 times 7 plus negative 1 times 1. And when you add those together, you get 13. And finally, third row, third column. 2 times negative 2 plus negative 1 times negative 1, and that gives us a negative 3. All right, so let's look at this next problem. It says find each product if possible, the product of x times w. So the first thing we want to do is go ahead and write our x with the matrix out there and our w with its matrix, and we're going to check the dimensions to see if we can actually even multiply this. So the first thing to do is check our matrix, and this one is 2 rows by 3 columns, and this one is 3 rows by 2 columns, and we can see that the columns equals the rows, and so we will be able to do this, and it's going to be a 2 by 2 matrix. All right, so let's just take a look at how we would do that. First of all, we're going to talk about our first matrix that we use is always going to deal with the rows. And our second matrix is always going to deal with the columns. All right, so let's just highlight our first row here. And let's highlight our first column here. All right. And so now that we have that, we're going to just start multiplying and adding. So we're going to say 4 times 3 plus 7 times 1 plus negative 2 times 2. All right, when we add all that together, 4 times 3 is 12, plus 7 minus 4 is 15. All right, so again, we're going to take the rows of the first matrix, highlight that, but not in black. Let's highlight it in this color instead. All right, and the second column, let's highlight the second column here. All right, so we're going to multiply again. Here we're going to say 4 times negative 2 plus 7 times 0 plus negative 2 times negative 1. All right, when we add that together, negative 8 plus 0 minus 2 is negative 6. All right, so far so good. Let's do our last 2. All right, again, the first matrix, we're going to always be dealing with our rows, so let's highlight our rows. And here we go. And we're going to also highlight our first column now. All right, so let's highlight the first column. And we're going to start multiplying again and adding. So what we're going to say is 5 times 3 plus 1 times 1 plus negative 1 times 2. All right, when we add that together, 15 plus 1 is 16 minus 2 is 14. All right, and now all we have to do is our last one. We're going to, again, the first matrix is going to deal with our rows. The second matrix is going to deal with our columns. All right, and then we just start multiplying through. 5 times negative 2 plus 1 times 0 plus negative 1 times negative 1. And when we multiply and add all that, negative 10 plus 1 is, let's see, negative 10 plus 1 is 9. Oh, that's 0. Minus 1 is negative 9. So here's our new matrix. All right, I know it's a lot of work, but it's really not that much brain work. It's just keeping track of where you're at. And I really do recommend that you use colored pencils or something to do this. And I'm going to show you another way in class that we can do it also. So matrices can be very useful. Even businesses can use matrix multiplication to find total revenues, costs, and profits. This next problem is a business application problem. It says 2 stores held sales on their videos and DVDs with prices as shown. Use the sales data to determine how much money each store brought in from the sales on Saturday. So you can use a product matrix to find the sales of each store for each day. Here you see I've set up the 2 matrices, and before we can multiply them out, we need to just check and make sure the dimensions work out. And so let's not forget, this matrices is a 2 by 2. This one has 2 rows and 3 columns, and we can see that the rows does equal the columns. So our new matrix is going to be a 2 by 3. All right, let's get started. I'm going to go ahead and have the answers here to show you. So let's remember, when you're talking about the first matrix, we're going to always be talking about the rows. So I'm going to highlight our rows. And the second matrix, we're going to be talking about our columns. All right, so what we're going to do is take the first and the first and multiply them together. And then we're going to take our second number and our second number down here and multiply them, then we'll add them together. All right, so then after we've done that, again, the first matrix is going to be our rows. Our second matrix, we're going to deal with our columns. Then we're going to multiply 895 times 31 plus 1195 times 48. And there those are. All right. First matrices, we deal with our rows. Second, we deal with columns. All right. And now we're going to multiply and add 895 times 25 plus 1195 times 42. All right, so now we have gone ahead and multiplied all of our rows on the top row. So now we're going to deal with the rows on our bottom row. All right, so once again, here's our rows on the first matrices and our column in the second matrices, or matrix. And now we're going to multiply 750 times 23, 1250 times 40. And that should have been a 40 in there. All right. And then we will, once again, rows are highlighted in the first matrix, column in the second, and we're going to go ahead and multiply again. 750 times 31 plus 1250 times 48. All right, and now we'll do our final one. Remember, the first matrix has rows, and the second matrix is our column. And then we multiply 750 times 25 plus 1250 times 42. All right, so what we need to do is go through and multiply and add all these things out. And when you do, that's a lot of work, but when you do, we come up with this amount right here, actually was there, and this amount is our Friday sales. All right, and so forth. So then this one corresponds in here. This one corresponds in here. All right, so what we can conclude on that, on Saturday, Video World made $851 and Star Movies made $832.50. All right, we're going to talk about a square matrix. A square matrix is any matrix that has the same number of rows as columns. And what that means when it says n by n, it just means like it's a 2 by 2 times a 2 by 2, all right, or a 3 by 3. They're the same, all right. The main diagonal of a square matrix is the diagonal from the upper left corner to the lower right corner, all right. So that's going to be called the main diagonal, all right. And so that's what we know about that. The multiplicative identity matrix is any square matrix named with the letter I that has all of the entries along the main diagonal equal to 1. So let's just see. Here's our main diagonal. I'll do a 3 by 3. It's going to have zeros here. And you may recognize this from before when we were doing some intercepts here. So here's our main diagonal. All right, and all of the other entries are equal to 0. Because square matrices can be multiplied by themselves, any number of times you can find powers of square matrices. Example 4 asks us to evaluate if possible, p cubed. So what that would look like is p equals the matrix times the matrix times the matrix. So each time we multiply, we have to check our dimensions. So we see this is a 2 by 2 and this is a 2 by 2. Obviously, our columns equals our rows, so our product matrix is going to also be a 2 by 2, and it always will be. So we could just keep on, for a 2 by 2, just keep on and keep on multiplying. So in order to do that, let's just take a look, following the steps that we've been doing before. I've already got them all written out for you. You could multiply them out and add each one and get your new matrix. And here it is. And then you continue doing it and continue doing it and continue multiplying the columns and the rows and the rows and the columns, adding them up, and finally, eventually you get to 64, 0, 74, 27. Unfortunately, I'm going to show you another way to do that on your calculator, so you won't always have to do all that work, but you will need to be able to do at least one problem by hand. And that is the end of our math lesson for today. I have a lovely math equation for you that you can look at and see if you agree with the algebra on it, and then you can see if you agree with the philosophy on it too. So anyway, hope you have a great day. I'll see you in class. Bye.